Welcome to the Deep Dive. Today, we're diving into the life of Julian Schwinger,
Oh, yeah.
a Nobel Prize-winning physicist. And honestly, getting into his story might make you feel a little inadequate about your own high school years.
Well, he was quite the prodigy, you know? I
yeah.
mean, just imagine like a teenager who's not, chasing the latest trends, but instead like completely engrossed in like physical review papers, like the kind that leave most seasoned physicists scratching their heads.
Yeah.
That was Julian Schwinger.
I'm struggling to picture that, to be honest.
Yeah.
I mean, physical review. I think my literary diet back then was mostly comic books.
Right?
And maybe like a daring trip to the school library's fiction section every once in a while.
Sure.
What drove that kind of intense focus at such a young age?
It seems like it was just pure, unadulterated passion for physics.
Really?
Yeah, it wasn't just a subject for him. It was like an obsession. And that's what led him to Townsend Harris High School and later City College of New York.
Right.
Both of them offered free tuition.
That's great.
And unsurprisingly, his brilliance in physics and math was just undeniable.
So it wasn't all smooth sailing, though, right?
Right.
I read that he had kind of a rebellious streak when it came to anything outside of physics.
Absolutely.
Yeah.
Schwinger actually said himself that he preferred the company of textbooks to classrooms.
Wow.
So he would often skip class and kind of delve into this self-directed learning.
Oh.
And his grades in non-physics subjects, just say they didn't quite reflect his genius.
Oh, so like the classic tale of a gifted mind.
Yeah.
Finding the traditional system a bit stifling.
Right.
But someone must recognize his talent. Of
Right,
course,
right.
you don't just like stumble into Columbia, especially
Right.
with grades like that.
Exactly. You're absolutely right. And that's where Isidor Isaac Rabi enters the picture.
Okay.
He was a physics professor at Columbia at the time.
Right.
And Rabi was kind of a visionary, a man who could spot raw talent,
Yeah.
even when it was masked by these unconventional academics. He saw something in Schwinger, and he became like his champion. He was convinced that this young man was destined for greatness.
What did he do? Did he like stage a demonstration?
Oh, no, he did something even better.
What's that?
He took Schwinger's unpublished work on quantum electrodynamics
No.
and presented it to Hans Bethe,
Okay.
who was like a titan in the world of physics at the time.
Right.
And even Bethe, a man not easily impressed,
Yeah.
was stunned by the depth and originality of Schwinger's work.
That's the kind of endorsement that you just can't ignore.
Exactly.
So that sealed the deal
It did.
for his admission to Columbia.
It did, and that was just the beginning of his remarkable journey.
Wow.
At Columbia, Schwinger flourished,
Yeah.
He immersed himself in his studies. He joined Phi Beta Kappa, and he graduated with a bachelor's degree in 1936.
Okay.
3 years later, at the age of 21,
Oh my gosh.
he earned his Ph.D. under Rabi's guidance.
21. That's mind-boggling.
Yeah.
I was barely figuring out how to boil water without setting off the smoke alarm at 21.
Right.
So he's at Columbia, thriving in the very environment he almost didn't get into.
Right.
What happens next?
Well, it's during those grad years that we see another facet of Schwinger's personality emerge.
Okay.
This like fiercely independent work style.
What do you mean?
Well, so he was awarded this traveling fellowship.
Okay.
And he got to work alongside some like luminaries in the field, like Gregory Bright and Eugene Wigner.
Oh, wow.
But instead of falling in step with their routines, he did something pretty unexpected.
Don't tell me he started wearing a cape and
Yeah.
only working in like the cover of darkness.
Not quite a cape, but close.
Oh.
He flipped his sleep schedule.
What?
Yeah, he chose to work through the night and sleep during the day.
I've heard about this. Wasn't that his way of like maintaining his intellectual independence even among all these other brilliant minds?
Yeah, that's the theory.
Wow.
He felt that working on this unconventional schedule gave him the space and solitude to kind of delve into his own ideas. Yeah.
Without being swayed by the thoughts of others.
That makes sense.
However brilliant those thoughts might be.
Right.
And get this nocturnal habit became a hallmark of his entire career.
Wow, so that's commitment.
Yeah.
Or maybe a mild case of mad scientist syndrome.
Maybe.
But either way, it clearly worked for him.
It did.
But let's talk about what really cemented Schwinger's place in, like, the pantheon of physics giants.
Okay.
His groundbreaking contributions to the field.
Ah, yes.
Yeah.
This is where things get really fascinating.
Okay.
To understand Schwinger's impact, you have to grasp the state of quantum physics at the time,
Okay.
particularly the challenges that were plaguing quantum electrodynamics,
QED?
or QED for short.
Okay.
That's the theory of how light and matter interact.
Right, but on a level of complexity that makes my brain hurt.
It's pretty complex.
Yeah.
But to simplify, imagine physicists trying to describe how light particles, photons,
Okay.
interact with matter particles like electrons.
Right.
The problem was their calculations kept spitting out infinities,
Ooh.
which, as you can imagine, isn't very helpful.
Infinite answers.
Yeah.
That doesn't sound like a very accurate model of reality.
No, it's not.
It's like asking how many grains of sand are on a beach and getting infinity as the answer.
Exactly.
Like maybe technically correct, but not exactly useful.
Not at all. And that's where Schwinger stepped in,
Okay.
wielding his mathematical prowess like a superhero superpower.
Okay.
He developed this technique called renormalization.
Renormalization.
Yeah, it's essentially a way of subtracting those pesky infinities
Okay.
to reveal the meaningful finite results hiding beneath.
So he like tamed the infinities and made QED actually useful.
Precisely. And this breakthrough had profound implications.
Wow.
Suddenly, physicists could make accurate predictions about the behavior of light and matter at the quantum level.
Okay.
This wasn't just like theoretical tinkering.
Right.
This revolutionized our understanding of the universe's fundamental forces.
Wow.
But hold on, because this is just the tip of the iceberg when it comes to Schwinger's genius.
Wait, there's more. Oh, yeah.
I'm already feeling overwhelmed.
There's always more with Schwinger.
Okay.
He didn't stop at renormalization.
Okay.
He went on to introduce non-perturbative methods in quantum field theory,
Okay.
a whole new way of tackling problems that traditional methods couldn't handle.
Wow.
For example, he calculated the rate at which electron-positron pairs are created by tunneling in an electric field.
Okay.
This is now known as the Schwinger effect.
Okay, even I can grasp the significance of that.
Right.
Creating matter from energy.
Yeah.
That's venturing into Star Trek territory.
It is.
It sounds like he wasn't just solving problems, he was rewriting the rules of the game.
That's a great way to put it.
Wow.
And his contributions didn't end there.
Okay.
He developed the modern understanding of field correlation functions.
Fields like magnetic fields?
Yes, but in quantum field theory, we're dealing with fields that represent all fundamental forces and particles.
Okay.
Think of them as like the fabric of reality itself. And Schwinger's work was instrumental in unraveling their complex interactions.
Yeah, okay.
He also provided these elegant proofs for the spin statistics theorem
Okay.
and the CPT theorem, two fundamental concepts in quantum mechanics.
I am officially in awe.
Yeah,
This man's mind was operating on a different plane of existence.
it seems that way.
So we covered a lot of ground already,
Yeah, we have.
from Schwinger's unconventional learning style to his revolutionary contributions to QED.
Right.
But I have a feeling this is just the beginning of our exploration into the life of this extraordinary physicist.
Oh, yeah, there's much more to come.
Okay, so we'll be back soon to delve deeper into Schwinger's world, including his intriguing rivalry with another physics icon,
Mm-hmm.
Richard Feynman.
Yes.
Welcome back to the Deep Dive.
Mhm.
We're continuing our exploration of Julian Schwinger and his work.
Yes.
And his impact on the field extends way beyond just his own research.
Mm-hmm.
We left off talking about some really complex concepts
Right.
of quantum physics.
Yes.
But I want to shift gears a bit and talk about Schwinger as a mentor.
Yeah, that's an aspect of his legacy that I think often gets overshadowed by his own monumental achievements.
Yeah.
But it's absolutely crucial.
I have to admit, I'm really curious about this side of him.
Yeah.
We talked about his unconventional work habits.
Right.
And this almost monastic dedication to physics.
Yeah.
Was he like this aloof genius who only emerged from his, nighttime calculations to impart wisdom to his students?
Not quite. He
Well,
was demanding, no doubt about that,
Yeah.
but also incredibly supportive and nurturing.
Oh, wow.
He genuinely cared about his students' intellectual growth,
Right.
and his track record speaks for itself.
Yeah.
He supervised a staggering 73 doctoral dissertations.
73.
73.
That's an entire physics department in itself.
It is, and it's not just the quantity,
Yeah.
it's the quality.
Okay.
4 of his students went on to win Nobel Prizes themselves.
Wow, that's an incredible legacy.
It is.
That's like a scientific dynasty.
It is.
Who are these Nobel laureates in the making?
Well, there's Roy Glauber,
Okay.
whose work on the quantum theory of optical coherence
Okay.
earned him the Nobel Prize in Physics in 2005.
Wow.
Then there's Benjamin Roy Mottleson,
Okay.
who shared the Nobel Prize in 1975 for his research on the structure of the atomic nucleus.
Okay, those are some serious contributions to the field.
They are
Who else?
Sheldon Glashow,
Okay.
a name you might recognize from our deep dive into the electroweak theory.
All right, yeah.
He shared the Nobel Prize in Physics in 1979 for his role in developing that theory.
It's like he had this knack for attracting and nurturing some of the brightest minds in physics.
He did.
It makes you wonder what it was like to be in his classroom,
Right.
to learn from a mind that was constantly pushing the boundaries of what we know about the universe.
Yeah, I can only imagine.
Yeah.
And to round out the quartet of Nobel laureates, there's Walter Kohn, who
Okay.
actually won the Nobel Prize in Chemistry in 1998
Oh, wow.
for his development of density functional theory.
So even chemists were benefiting from the Schwinger school of thought.
That's right. It really highlights his broad impact across scientific disciplines.
It does, but, when you talk about cowering figures in physics,
Yeah.
it's almost impossible not to bring up Richard Feynman.
Yes, the Feynman-Schwinger dynamic.
Yeah.
It's one of those classic pairings in science.
Right.
Like Einstein and Bohr or Watson and Crick.
Yeah.
Two brilliant minds approaching these similar problems,
Yeah.
but with vastly different styles.
It's often portrayed as like a rivalry.
Yeah.
Almost like a scientific duel.
Right.
Was it really that adversarial?
I think rivalry might be a bit strong. It was more of a contrasting approach
Right.
and a healthy dose of professional friction.
Okay.
Both Schwinger and Feynman were working on quantum electrodynamics,
Right.
trying to make sense of those pesky infinities we talked about earlier.
Right. So they had the same goal, but took very different paths to get there.
Exactly. Schwinger, with his deep commitment to mathematical rigor,
Okay.
favored this highly formal approach.
Okay.
He was like a master of abstraction,
Right.
working with these things called local field operators.
Okay.
He believed that the true beauty and power of physics lay in its mathematical structure.
That makes sense, considering his solitary work style and his love of diving deep into equations.
Right.
What about Feynman?
Yeah.
He always seemed to have a more playful, almost intuitive approach to physics.
That's a great observation.
Yeah.
Feynman was famous for his Feynman diagrams.
Yeah.
Those whimsical-looking squiggles and arrows that you often see on physics blackboards.
I've always wondered what those diagrams actually represent.
Yeah.
They look like something out of a Dr. Seuss book.
They do have a certain charm to them,
Yeah.
but they're actually incredibly powerful tools.
Really?
Yeah. Feynman diagrams provide this visual language for representing complex interactions between particles. They allowed physicists to calculate and conceptualize these interactions in a way that was far more intuitive
Right.
than traditional mathematical methods.
So Schwinger, the mathematical purist,
Yeah,
and Feynman, the visual storyteller.
I like that.
Did they respect each other's work despite their differing approaches?
Absolutely.
Wow.
Even though their styles were like diametrically opposed,
Yeah.
they recognized each other's genius.
Okay.
There's a famous quote from Schwinger about Feynman diagrams.
Okay.
He said they brought computation to the masses, comparing them to silicon chips.
That almost sounds like a backhanded compliment.
Yeah.
Is he suggesting that Feynman was oversimplifying things?
I don't think so.
Okay.
I think what Schwinger was getting at is that Feynman diagrams, while brilliant in their simplicity, might distract from the deeper, more abstract mathematical foundations of quantum field theory.
Okay.
He worried that physicists might become too reliant on these diagrams and lose sight of the elegant mathematical framework underneath.
So a difference in philosophy more than anything else.
Precisely. It's a debate that continues to this day.
Really?
Is the true essence of physics found in its mathematical formalism,
Yeah.
or in its ability to provide these intuitive visual explanations?
I guess it's a bit like asking, is the beauty of a symphony in the sheet music?
Yes.
Or the experience of hearing it perform?
Exactly. Both have their own value and appeal.
Right.
And in the case of Schwinger and Feynman, both approaches ultimately contributed to the advancement of quantum electrodynamics.
That's pretty amazing.
It's a testament to the fact that there are often multiple paths to understanding the universe.
And perhaps having these contrasting viewpoints, these intellectual sparks flying back and forth. That's what ultimately drives progress in science.
That's a great point. The history of science is filled with these examples of productive tensions, these clashes of ideas that lead to breakthroughs.
Right.
And in the case of Schwinger, his independent spirit and his willingness to forge his own path led him to develop a whole new approach to particle physics, one that would set him apart from the mainstream and spark further debate.
Oh, yeah. Source theory.
Yes.
We touched on it briefly before.
We did.
It sounds like this was a pretty significant departure from the prevailing trends in particle physics.
It was, to understand source theory, You need to grasp the context of particle physics in the 1960s.
Okay.
The field was becoming increasingly focused on developing these fundamental theories,
Okay.
like quantum chromodynamics,
Okay.
that sought to explain the behavior of elementary particles and the forces that govern them.
So the quest to find the ultimate building blocks of the universe.
Yes.
And the rules that bind them together.
Exactly. And this quest often involved these complex mathematical frameworks and abstract concepts.
Yeah.
But Schwinger, ever the iconoclast, decided to take a different route.
What did he find so dissatisfying about the direction particle physics was taking?
He felt that this emphasis on abstract theories was leading physicists away from observable phenomena, the tangible realities that we can actually measure and experiment with.
So less about the why and more about the what.
Precisely.
Yeah.
Schwinger's source theory was what's known as a phenomenological approach.
Phenomenological approach.
It focused on describing and predicting observable phenomena rather than delving into these deep underlying mechanisms.
So instead of asking what are the fundamental particles and forces that make up reality,
Right.
he was asking how can we accurately describe and predict the behavior of the particles that we actually observe.
Exactly.
Okay.
And this was quite a departure from mainstream thinking in particle physics at the time.
Was this a case of if you want something done right, you have to do it yourself?
Possibly.
Did he feel like he needed to create his own framework?
Yeah.
To explore the questions that truly fascinated him?
It seems so. He was never one to shy away from going against the grain, even if it meant going against the tide of prevailing thought.
Right.
And his commitment to this new approach would ultimately lead him to make a major life change.
I'm sensing another plot twist here.
You're right.
What happened?
Schwinger's work on source theory was met with considerable resistance from his colleagues at Harvard.
Really?
They were deeply invested in the fundamental theories that were gaining prominence.
Okay.
And Schwinger's approach was seen as a distraction, even a step backward.
That's incredible.
I know.
Nobel laureate, a giant in the field facing pushback for his ideas.
It happens more often than you might think.
Really?
Science, despite its reputation for objectivity, isn't immune to the dynamics of human ego and the allure of popular trends.
Right.
So
what did Schwinger do?
Well, he tried to convince his colleagues. You know, he defended his approach.
Yeah.
But the friction continued.
Right.
And eventually it led to a decision that shocked the physics community.
He left Harvard.
He did in 1972. He packed up his equations, his unconventional work habits, and his unwavering belief in source theory, and moved to UCLA.
Wow. That's a bold move.
It is.
Leaving one of the most prestigious institutions in the world.
Right.
Because your ideas weren't immediately embraced.
Exactly.
Speaks volumes about his conviction.
It does.
Was he welcomed with open arms at UCLA?
He was.
Yeah.
UCLA provided a more receptive environment for his unorthodox approach.
Okay, good.
And it was there that he continued to develop and refine source theory, even as the mainstream of particle physics continued to focus on fundamental theories.
It's fascinating how a single mind can have such a divergent path, even within a field that seems as unified as physics.
Right.
But I have a feeling this isn't the end of Schwinger's story.
Oh, no.
He seems like the kind of person who never stopped questioning.
Right.
Never stopped pushing the boundaries of what was known and accepted.
You're absolutely right, even as he pursued his own path with source theory.
Yeah.
Schwinger's insatiable curiosity led him to explore other controversial areas of science, areas where his willingness to challenge the status quo would once again put him at odds with the scientific establishment.
Okay, now I'm really intrigued. We'll have to delve into those controversies in Schwinger's later years when we return for the final part of our deep dive.
We will.
Welcome back to the deep dive. We're wrapping up our exploration of Julian Schwinger's life and work. And let's just say this final chapter is filled with some twists and turns worthy of a scientific thriller.
It is.
Before the break, we left off with Schwinger leaving Harvard for UCLA.
Right.
A move that was prompted by the resistance he faced for his unique source theory.
Yes, and while he found a more receptive environment at UCLA, Schwinger's independent streak and his tendency to challenge conventional wisdom didn't exactly fade away in the California sunshine.
So what new scientific frontiers did he set his sights on?
Well, in his later years, Schwinger became fascinated by a topic that even today is shrouded in controversy: cold fusion.
Cold fusion. That's the holy grail of energy production, right?
It is.
The idea of achieving nuclear fusion at room temperature, essentially unlocking a limitless clean source of energy.
Right.
But I thought it was largely dismissed as science fiction.
It was and still is a highly debated topic.
Yeah.
But Schwinger, with his characteristic boldness, kind of jumped headfirst into the fray.
Yeah.
He was intrigued by the potential of cold fusion and believed that it deserved serious scientific investigation.
Wow.
Despite the skepticism and even ridicule from many in the scientific community.
So even a Nobel laureate like Schwinger
Yeah.
wasn't immune to the allure of a scientific mystery,
It seems not.
even one that many considered a dead end.
Right.
Huh.
He dove into the research, published several papers on the subject,
Okay.
but his work was met with some pretty stiff resistance from the American Physical Society,
Really?
which refused to publish his findings in their prestigious journals.
That's surprising. You'd think a Nobel Prize winner would have a bit more clout in the scientific community.
You would think so.
Why the pushback?
Well,
Was it purely because the idea of cold fusion was so controversial?
that was certainly a major factor.
Yeah.
Cold fusion had become something of a scientific taboo,
Okay.
associated with fringe theories and
Right.
questionable experimental results.
Yeah.
Many physicists felt that pursuing it was a waste of time and resources,
Okay.
and that Schwinger, by lending his credibility to the topic, was damaging the reputation of the field.
It sounds like a clash between the old guard clinging to established norms
Yeah.
and a maverick who was willing to explore unconventional paths even at the risk of his own reputation.
Right.
How did Schwinger react to this rejection?
He was deeply disappointed, even angered by the response.
Like,
He saw it as an attack on academic freedom,
wow.
a stifling of open inquiry.
Okay.
He felt that the American Physical Society, by refusing to even consider his work, was engaging in censorship, not scientific evaluation.
So this wasn't just about cold fusion itself.
Right.
It was about the very principles of how science should be conducted.
Exactly.
The freedom to explore ideas, even those that challenge the status quo.
Precisely. And Schwinger, a man who had built his entire career on challenging conventions, wasn't about to back down.
Wow.
He resigned from the American Physical Society in protest,
Wow.
making a very powerful statement about the importance of intellectual freedom in science.
That's a pretty dramatic move.
It is.
It shows just how deeply he believed in these principles.
It does, and his words on the matter are worth reflecting on.
What did he say?
He wrote, "The pressure for conformity is enormous.
Wow.
I have experienced it in editors' rejection of submitted papers based on venomous criticism of anonymous referees. The replacement of impartial reviewing by censorship will be the death of science."
Those are powerful words.
They are.
A stark warning about the dangers of allowing dogma to stifle scientific exploration.
Right. And they serve as a reminder that even in a field as seemingly objective as science,
Right.
human biases and the fear of the unconventional can hinder progress.
It makes you wonder how many potentially groundbreaking ideas have been dismissed or suppressed
Right.
because they didn't fit the prevailing narrative.
It's a question worth pondering.
It is.
But let's get back to Schwinger.
Okay.
Even as he battled these institutional challenges,
Yeah.
his scientific curiosity never waned.
Okay.
In fact, he continued to explore new and often controversial ideas
Really?
right up until the end of his life.
I'm starting to see a pattern here.
Yeah,
Schwinger never met a scientific dogma he didn't want to challenge.
that's right.
What was his final act of scientific rebellion?
In his last years, Schwinger became intrigued by a phenomenon called sonoluminescence.
Sonoluminescence.
Yes.
That sounds like something out of a science fiction novel.
It does have a certain otherworldly quality to it. Imagine a tiny bubble in a liquid collapsing in on itself due to the vibrations of sound waves.
Okay.
As it implodes, it emits a burst of light,
Wow.
a tiny spark of energy released from the heart of this collapsing bubble.
It's amazing that something so small can create such a dramatic effect.
It is.
What was Schwinger's take on this phenomenon?
Ever the theoretical physicist, he sought to develop a quantum explanation for sonoluminescence.
Okay.
He proposed this novel theory, one that differed from the prevailing explanations at the time.
Okay.
And true to form, his ideas were met with skepticism from many in the field.
So even in his final act, Schwinger was pushing boundaries, challenging conventions,
Yeah.
and reminding us that the quest for understanding never truly ends.
Exactly. His theory about sonoluminescence,
Yeah.
while not widely accepted,
Right.
exemplifies his lifelong commitment to seeking new explanations,
Right.
to venturing beyond the comfortable confines of established knowledge.
Okay.
It's a testament to his intellectual restlessness,
Yeah.
his refusal to let age or the opinions of others dampen his scientific curiosity.
It's a powerful legacy.
Oh, it is.
Julian Schwinger passed away in 1994 from pancreatic cancer.
Yes.
But his impact on physics and his spirit of fearless inquiry continue to inspire generations of scientists.
Absolutely. He reminds us that the path of scientific discovery
Right.
isn't always linear or predictable.
Yeah.
It requires not just brilliance, but also courage.
Right.
The willingness to embrace unconventional thinking,
Yeah.
to challenge the status quo,
Okay.
and to pursue knowledge wherever it may lead,
Right.
even if it takes you down a lonely or controversial path.
And sometimes those lonely paths lead to the most profound discoveries.
They do.
Well, thank you for joining us on this deep dive into the life and work of Julian Schwinger,
My pleasure.
a physicist who dared to be different, who challenged conventions,
Yes.
and who, in doing so, expanded our understanding of the universe and the very nature of scientific inquiry.
He did.